Hey everyone. If you're gearing up for the HKDSE ICT exam, you are in exactly the right place. Today, we are going to tackle one of those topics that can feel a bit tricky: computer modes of operation. Understanding the difference between batch, real-time, parallel, and distributed processing. It's not just some random theory, you guys. Nailing this is the key to unlocking those top marks on your exam. So let's break it all down, nice and simple.
So here's our game plan. First up, we'll look at why this is such a big deal for the exam. Then, we're going to use some really simple analogies to make these ideas stick. And finally, the best part, I'm going to show you exactly how to structure your answer to grab every possible point. Sound good? Let's go.
All right, so why are we starting here? It's simple, really. This isn't just a good-to-know thing. Nope. This is a required part of the syllabus, and let me tell you, it's a favorite question for examiners. Getting this right, it's pretty much non-negotiable.
Okay, now lean in, because this is important. Look at that first word right there on the slide, distinguish. Seriously, this is like a secret clue the examiners are giving you. They don't want a list of definitions. No way. They want you to actively compare and contrast. You got to explain the differences and, more importantly, the reasons why you'd pick one mode over the other. And trust me, that skill, that's what separates a basic pass from a top-tier grade.
So, this is the big puzzle we're trying to solve, right? How on earth can a computer do so many different things? How can it handle millions of boring bank calculations one minute and then run your super fast-paced online game the next? Well, the answer is that it has a whole toolkit of different modes of working. And knowing which tool to use for which job, that's exactly what we're going to master today.
Let's dive into our first big comparison. And this one is all about timing. It's about pace. Is the job something urgent that has to happen right now, or can it wait a bit? Can it be done with a whole bunch of other tasks later? This single question is the fundamental difference between batch and real-time processing.
To make this crystal clear, just think about it like this. Batch processing, that's like doing your laundry. You don't wash one shirt at a time, right? No, you wait, you collect a whole pile, and you wash it all together. It's efficient, but there's a delay. Now, real-time processing is like a chef in a restaurant. When you order your food, the chef starts cooking right away. There's no waiting for other orders to pile up. It's all about that immediate response.
In this table, this is where we turn that simple analogy into actual exam points. Just look at how these features line up perfectly. Batch processing is awesome for huge, non-urgent jobs like calculating payroll or sending out utility bills. Why? Because it's super efficient. The trade-off, though, is that delay. Real-time is the complete opposite. It's all about that instant, no-delay response that you absolutely need for things like flight control systems or online gaming, where even a tiny lag could be a total disaster.
All right, our next comparison is a bit different. We're shifting our focus from when a task gets done to where it gets done. Are we using a bunch of processors inside one single computer, or are we using a whole bunch of different computers all linked up over a network?
Let's stick with our awesome chef analogy, because it works perfectly here too. So, parallel processing. Imagine you've got a team of chefs, all in one big kitchen, all chopping vegetables for the same giant pot of soup. They're in the same place, sharing the same tools, all focused on one big goal. Now, distributed processing. That's like catering a massive banquet. You've got one chef in one kitchen doing the appetizers, another chef in a different kitchen making the main course, and a third somewhere else making dessert. They are in totally separate locations and have to talk to each other over walkie-talkies or, a network to get the whole job done.
And here's how that all plays out in the tech world. With parallel, everything's inside one box, right? All the CPUs can talk to each other using super fast shared memory. The main goal here is just one thing: speed. How can we get this one really complex task, like rendering a 3D movie, done faster? But with distributed, we're talking about a whole network of computers. The goal here isn't just speed, it's about scale and being reliable. How does Google handle millions of searches at the exact same time without crashing? Simple. They share the massive load across thousands and thousands of machines.
Okay, time for our final concept: virtualization. Now, this one's a little bit different. It's not really a processing method in the same way as the others. It's more like a clever magic trick that lets us use our computer hardware way more efficiently.
To put it really simply, virtualization is all about making one big, powerful computer pretend that it's actually a bunch of separate, smaller computers. Just think of a single talented actor who can play 10 completely different characters, and you believe every single one.
You've only got one physical machine, but it can be running Windows, Linux, and Mac OS all at the same time, and each of those operating systems thinks it has the entire computer all to itself. Pretty cool, huh? So how does this magic trick actually work? Well, on this slide, you can see the 3 layers. You start with your physical hardware, your actual server. Then, you install a special piece of software called a hypervisor. Think of the hypervisor as the magician. Its whole job is to slice up the real hardware resources and create multiple, totally independent virtual environments. And each one of those environments is called a virtual machine, or VM. It's the illusion. Each VM thinks it has its own dedicated computer, but really, it's all just an illusion perfectly managed by that hypervisor.
Okay, deep breath. We've learned all the concepts, but let's be real. Knowledge is pretty useless if you can't actually apply it in the exam. So let's get to the most important part. How do you use all of this to write a killer exam answer?
This right here, this is the critical warning, and it's based directly on feedback from the people who will be marking your paper. The #1 mistake students make is just listing facts. Batch processing does this, real-time processing does that. That is not enough. You have to actively compare them. Use words like whereas, in contrast, or on the other hand to show the examiner that you truly understand the relationship between them. That's the secret sauce.
All right, this slide, this is your golden ticket for revision, your ultimate cheat sheet. For every single mode, you just need to nail 3 things. What's its main characteristic? What's the core question it's trying to answer? And, of course, a classic example. Think about it. Is it okay to wait? Boom, that's batch. Does it have to happen right now? That's real time. How do we make this one single task faster? Hello, parallel. See, using this kind of framework makes you think comparatively, and that is exactly what the exam is asking for.
So let's wrap this up with the winning strategy. First, and I'm going to say it again, always compare and contrast. Second, use those simple analogies, the laundry, the chefs, the magician, to lock the core idea in your brain. Third, really focus on the key differentiator. Is the main difference about pace, now versus later? Is it about place, one computer versus many? Or is it an illusion of hardware? And finally, make sure you pepper your answers with those important keywords that show you know your stuff. So, I'll leave you with this little thought experiment. The next time you're on your phone or computer, just think about what's happening behind the screen. You're using all of these modes at once. Distributed systems are fetching that movie you're streaming, real-time processing is handling your inputs in that game, and it's all probably running on virtualized servers out there in the cloud. When you can see how they all work together, that's when you know you've truly mastered this topic. Good luck with your studies, you've got this.